A roving of 2 any count is fed to a ring frame set with a mechanical draft of 30. If the length of the drafted strand delivered from the nip of the front rollers is reduced by 3% due to twist, the count in any of the yarn rounded off to one decimal place is. So the yarn count is given in any. Any is an indirect count. So the draft is delivered count upon feed count. So the delivery count, feed count is set to be 2 NE and the draft is 30 mechanical draft. So 30 into 2 will become your delivery count, delivered count, and it is 60 NE. And when you will, this will to be 60s NE. It is delivered count. But due to reduction in length due to twist is 3%. So if how much the length will be reduced due to twist, reduction in length due to twist is 3%. 3% of what? 3% of 60. It will come out to be 1.8. And if you know that if the length is reduced, then the yarn becomes finer or coarser. If the length is reduced, then the yarn will become coarser. That is, if the value of any is less, then the yarn is coarser, and if the value of any is high, then the yarn is finer. If for example 20 is any and 40 is any, which yarn is finer and which yarn is coarser? So 40 is any yarn is finer, whereas 20 is any yarn is coarser. And if we talk about the text system, it is a direct system, and here 40 text value is coarser and 20 text value is finer. So this is a simple framework that you need to be clear with. So the if the yarn is so the count of the yarn due to after the reduction in length would be, so count in any of the yarn would be 60 is any minus 1.8. 60 minus 1.8, it would come out to be 58.2. 58.2 NE would be the right answer, and you have to write in one decimal place. So the correct answer is 58.2. It was a 2-mark question of GATE TF 2021. I think it is very much clear to you. Now coming on to the next question. In a 3x3 drafting arrangement, the diameter of all bottom rollers is 28 mm, the back zone draft is 1.3 and the front zone draft is 6. If the back bottom roller is eccentric, then the wavelength in mm of the front zone draft is 6. If the back bottom roller is eccentric, then the wavelength in mm of the resulting fault in the drawn sliver rounded off to 2 decimal places is. In this question, you have to find the wavelength of the resulting fault of the drawn sliver. In this case, how it is arranged? It is arranged in this pattern. These are the rollers that are arranged in this fashion. 3x3 drafting rollers means 3 rollers above and 3 rollers in bottom, and these are arranged in a similar pattern. So, and the diameter is said to be 28 mm. 28 mm 28 mm is diameter. 28 mm is diameter. So if we calculate the front zone draft as 6 and the back zone draft is 1.3, so the total draft is total draft is back zone draft into front zone draft, means 1.3 into 6, that will come out to be 7.8. It is the total draft. And if we have to calculate the wavelength of the resulting fault in the drawn sliver, then the wavelength of resulting fault is pi d into total draft. It is a formula, so pi is 3.14, diameter is given it out to be 28, and the total draft is set to be, we have calculated is 7.8. When you will solve this, then it will come out to be around 686.1 mm. And so you have to write in two decimal places, and the correct answer is 686.10. It is the wavelength of the resulting fault in the drawn sliver is 686.10. It is the correct answer. I think you have understood. This was also a 2-mark question of NAT type from the drafting arrangements. So you need to be clear what is the formula for total draft and what is the formula for wavelength of the resulting fault pi d into total draft, because total drafting helps in the improving the orientation of the fiber, resultant fiber. So the total draft is calculated using the back draft multiplied by the front zone draft. So in this case it was eccentric. Now coming on to the next question. For a given woven fabric, the fractional cover is zero point 0.5 for both warp and weft. The fractional cover of the fabric is rounded off to 2 decimal places is. So in this case, what is given is C1 is warp cover is said to be 0.5 and weft cover C2 is 0.5. It is given. So what is the formula for the fractional cover of the entire fabric including both warp and weft? So fractional cover is equal to, if you know the formula, fractional cover C is equal to C1 plus C2 minus C1 C2. C1 is 0.5 plus 0.5 minus 0.5 into 0.5. 1 minus 0.25, it will come out to be 0.75. So the correct answer is 0.75. And you have to write in 2 decimal places, so the correct option is 0.75 only. So it is the answer. I think it is a simple question, and it was also a 2-mark question, direct straightforward question. In this question sometimes they ask for cover factor. So cover factor is nothing but a 28 times C. So K is represented by cover factor, so you can calculate the cover factor as well. If you have calculated the fractional cover of the entire fabric. So it is not a tough question. You need to be clear with the fundamentals of the basic of what type of questions are asked in this GATE examination. I think it is very much clear to you. You must have understood by now the pattern of the GATE examination in the latest years, that is 2021, 22. So how they do not ask very tough questions. Some questions are no doubt very tough, but majority of the questions are doable, and you have to focus on the doable questions only. You do not need to solve 100% of the questions. You have to solve just 80 to 90% of the questions, but the major thing in the GATE examination is your accuracy. Whatever you solve, just have your accuracy to about 90% and you will ace the examination. I think it is very much clear to you. Now coming to the next question. For a shuttle loom producing plain woven fabric, if each of the dwell periods of the shedding cam corresponding to 1/3 of the crankshaft rotation, the sum of the two dwell periods of the cam in degree is. You have to find the sum of the two dwell periods at the corresponding things. So if you know some of the two dwell periods, so if the total dwell is about 360 and then it comes out to be 360. So if each dwell of the shedding cams correspond to 1/3 of the crankshaft rotation, 1/3 means 1/3, and sum of the two dwell periods, so two dwell periods are 0 degree and 360 degree, means 2 pi respectively. So 1/3, 0 plus 360 degree, So 360 degree upon 3, it will come out to be 120 degree. So sum of two dwell periods of the cam, sum of two dwell period of cam is come out to be 120 degree. I think it is clear to you ki how it is calculated 120 degree, because the two dwell periods of the cam are, first one is at 0 degree, and when the cam is rotated fully, then it covers 360 degree, means full rotation covers 360 degree 2 pi, and it half one is 180 degree. So 2 pi rotation, and it is said to be one third, as it is given in crankshaft rotation, one third the crankshaft rotation. So we have divided by this, and we have found the answer very easily. I think it is clear to you.